Myself in the Finns YouTube as well. Okay. So, welcome to the third session for today. This is the session for class 9 and above. So, if you are in class 9 and above, you will enjoy it. If you are not, you can still stick around. This could be interesting to you as well. Uh, as you all know, these are seminars building up to the Bose Mathematics Olympiad, which will be held in the month of July. So something to keep in mind. I'll send you the links and everything so that you can sort of look into that as well. Okay. So maybe I can stop the video here. Okay. Yeah. Okay, now we have this. Today we will be talking about one of the most powerful tools of solving geometry problems, and that is related to area. And it's not as much about counting or calculating the area, because we all know how to do it more or less. We know how to calculate the area of a square, a rectangle, all those things we know. What we do not know, or rather what we would like to know, is how to use simple intuition, to find out the area and find out an area in reference to another area. So can everyone hear me loud enough? If you can, please ask others to sort of say that you can. Okay, they can raise their volume or something. Okay. All right. So let's start with this problem. This is a very beautiful problem. It's from a Canadian Mathematics Olympiad, and it's something like this: that there is a tablecloth. This, don't worry about this white region, not this white region. Just focus on the tablecloth right here. So this particular tablecloth has a regular pattern. It's a black and white, it's a black and gray sort of pattern. As you can see, it's a black and gray, and it is sort of checkered. It is checkered in this way. So what we really want to know is that what percentage of the tablecloth is black. So if you look at the entire tablecloth, what percentage of this tablecloth is black? That's the question that we want to answer today. Okay. Now, instead of calculating the actual area and everything, we can do this in a more intuitive way. We can do this in a more visual way. So let's see how we can do this. We can start with noticing that these are the little squares, right? So let me zoom a little square. So maybe I can say zoom it. Well, I'm using zoom as well, so makes sense, I guess. Okay, so let's zoom a little square. Let me draw it like this. Let me enlarge its little square. And let me draw the black portion in red here. So maybe something like this. And maybe I can shade this thing in red so you can see what's what, right? Okay. Now, the question is this. So due to a very high volume of participants, if you are logged off, you can always go back to YouTube and watch this broadcast in YouTube, and you can chat there as well. So what I'll do is I'll send you the YouTube link as well. Okay, so that's So in case if you miss it, because there is a huge number of candidates attending, we have had house full in the last 2 sessions. Okay, so coming back to this is a very, so we want to solve this in a very intuitive way. We don't want to solve it using any formula, okay? So how do we do this? You look at this square and you divide it into 4 regions, 4 parts. So maybe I can use the blue thing to do that. So let me divide this in this 4 parts. Or actually I could do the green one as well. So let's use the green one. Okay, now can anyone tell me if this square, whatever the area of this square is, what is the area of each of these small pieces? So if the area of this square is 1, let's suppose that's true. If the side length of this small square is 1, what is the area of these small pieces? Maybe I can mark them in orange or something. Yeah. So how many parts have I divided this square into? Excellent, excellent. As many of you realize that each of these parts is 1/4 of the actual square. Now, you have to be very careful. This is something that I do not want you to do. I do not want you to actually calculate the area of the small square, because that you can always do, isn't it? Because this part is half. If the entire thing is 1, then that little part is half. This is half. And if you know the area formula, then it is half times half. That's 1/4. So you know this, right? All of you know this. But my request to you is, do not think like this. For a moment, think about yourself as a cave person, that you do not know any formula. Forget about all the formulas you know for the moment, okay? We will come back to the formulas in a moment. But for the moment, let's look at this from a very childish cave person perspective. What I've done is I have split this square into 4 parts. And by symmetry, each of these 4 parts look equal. So it is 1 out of 4 square. Excellent, as Ashia Banu is very nicely pointing out. It's one of these 4 little squares which by symmetry look equal. So instead of using any formula, we should think of it more visually, and we should think of this little square as 1/4 of this square. Okay, now in this little square, there is a red region and there is a black region. There is a red region and there is a black region. What do you think about this red and black region? What about the areas of the red and black region? They're exactly half of this small square, right? They are equal. Yes, they are equal. Correct. So now think about it like this. The black region of the entire square and the red region of the entire square, this big square now. I'm talking about the big square, comprising of all the small squares. I'm thinking about the big square now. The black region and the red region, they will also be equal, isn't it? Is that not right? Okay, so the black and the red are equal even in this particular square, in the larger in this square, right? Okay, so that's okay. See, I'm proceeding absolutely visually. I'm not going to use any formula until the last step of the process. Okay, Okay, is my voice breaking? Can all of you hear me clearly? I think it's clear. Okay, so if you can hear me clearly, then please tell others. I mean, one of you can monitor and just tell others that you can. Thank you. Okay, that's great. So we have this black and the red now. Okay, now let's go back to this original problem, this particular problem. How many these small, so if this is black and this is red, this is half and this is half, and together they make it one, right? Great. So how many of these squares are there? How many of these squares are there in the picture? How many of these squares are there in the picture? Okay, excellent. There are 16 such squares. 16 squares. So half of these 16 squares is black and half of it is white, right? Half of it is black and half of it is white, correct? Okay, now let's see. We are almost at the last step. So the entire square, let's count the entire square, 1, 2, 1, 1, 1. So what is the area of the largest square or the very big square or the tablecloth? What is the area of the tablecloth? Think about it. Excellent. Audrija Ghosh has rightly pointed out, since this is 1, 1, 1, 1, 1, this is 5. This is 5. Since the side length is 5 and this is 1, 1, 1, 1, 1. So the side length is again 5. The entire tablecloth is 25 units. Is the tablecloth. How much of it was the black portion? So the black portion was how much of it? So how is it 16? Samarth, do you see that you can just simply count? You can do this like this. So this is 1, I'm doing it in orange. 1, 2, 3, 4, 5. And then there are 5 of them here. So 5, 5, 10. And there are 3 here and 3 here. So 10 plus 6 is 16. So there are 16 of these small boxes. Half of it is black. Half of it is black. So what is half of 16? What is half of 16? Okay, that's 18, 8, right? Half of 16 is 8. So area of the entire tablecloth is 25. Area of the black portion is 8. So now you can find the percentage, right? So how do you find the percentage? Okay, you say, okay, 25 is 100%. 100% means all of it. When I say something is 100%, it basically says all of it. So most of you know this. So 1 is 100% by 25, that's 4%. You wanted to know the black portion. So 8 is 4 times 8, that's 32%. That's the answer. Now, you see, thank you, Adrija, for helping us out. It helps the flow of the class that you told someone that the voice is clear. Thank you. Okay, now focusing on this, you see, the problem itself is not that important. I mean, there are thousands of problems out there, and you can probably never solve all of them, of course. There are infinitely many of them, I guess. The real thing is the way you are thinking about this problem. Notice how little of the formulas we used. So when we counted 5 times 5, the area inside of this is also taken care of. So nothing to worry about it. The black part was taken to be half of the 16 small squares. Half of the 16 small squares. Okay. And there are 16 small squares, and exactly. We are just breaking down shapes. Excellent, Ritam. That is the point. We are just breaking down shapes, and we are saying, okay, this shape is half of the bigger shape. So its area must also be exactly half. Thank you, Samarth. Thank you. Okay, so now this particular thing has a larger implication. So I'll just give you a hint of what can be done with this. So there is a theorem called Carpet's theorem. So we discussed this in our Math Olympiad program. And the Carpet's theorem it's somewhat like this. It is infinitely, it's much more complicated problems are handled just using this sort of a visual intuition. If you can see visually what's going on, that is how you solve problems using the Carpet's theorem. So I have not discussed that theorem in this particular class because it's a bit more complicated, but this is the beginner's intuition for it. Okay, thank you. Now let's move on to the next problem, which is also related to area. This next problem is also related to area. This is a parallelogram problem. Okay, so what is a parallelogram? A parallelogram is a quadrilateral whose opposite sides are parallel to each other. So in this picture, AD is parallel to BC and AB is parallel to CD. So that's what a parallelogram is. Its opposite sides are parallel to each other. Opposite sides are parallel to each other. So look at this. If this is a parallelogram, if ABCD is a parallelogram, what is given? Its area is given to be S. Area is S. The area of this parallelogram is given to be S. Okay, that's awesome. Maybe I can just close this. So area of this is given to be S. It's given that the diagonals of this parallelogram intersect at the point O. So the diagonals of this parallelogram intersect. So I'll draw the diagonals in red. They intersect at the point O. Okay? The diagonals of the parallelogram intersect at the point O. It's also given that a random point M is marked on CD. A random point M is marked on CD. Okay? AM will intersect BD. So maybe I can draw this in green. This is BD. This is AM. And AM intersect BD at the point E. AM intersects BD at the point E. Okay? And what else is given? BM intersects AC at the point F. BM intersects AC at the point F. So this is also given. So this is all given data. Notice how I have broken down the problem into pieces. This is very important. When you get a problem, whether in Maths Olympiad, whether somewhere else, you have to break down the given data into small pieces which can be processed more easily. Okay. Now, area of AED and BFC. So AED, maybe I can draw it like this. AED, this is the shaded region. Area of AED plus area of BFC, this is given to be 1/4 of S. So what do we want? We want to find out the area of this little portion. Maybe I can do this in red. So our goal is to find out the area of EOFM, the area of EOFM. Oh, I should mention that this is a problem from either American mathematics competition or Canadian Math Olympiad. So one of the math candidates, so one of those two. It has been also used in the Indian Math Olympiad of PRMO in a different flavor. So the same problem has been used. So anyway, it's Maths Olympiads are like this. If one country designs a problem, since the syllabus is sort of the same all across the world, they take problems from one country to another country and sort of use it. And most of them are actually copying it from Russian Olympiads. So because Russians and Romanians started it first. So at any rate, that's happening here. So anyway, what is the area of triangle or quadrilateral EOFM? It's given, so this is given data that AED plus BFC, actually it's 1/8 of S. I'm sorry, this is 1/8 of S. AED plus BFC is 1/8 of S. AED plus BFC is 1/8 of S. So this is a very beautiful problem. You can give it a try, a little bit try on your own. But I'll give you the first hint to try this problem. The first hint to try this problem. And the hint is really simple. What is the hint? The hint is this, that suppose you have a line like this. Okay? Let's call this line MN. Okay? Let's call this line MN. And suppose this point, there is a point here, there is another line here, sorry, another line here. Let's call this one L. So L is parallel to MN, suppose. L is parallel to MN. Now we draw two triangles. One is like this, and maybe another one is like this. This is X, this is Y. This is X, this is Y. So what is the setup? The setup is that we have MN parallel to XY. MN parallel to XY. And we have chosen 2 points X and Y from this parallel line to MN. The claim is, and this is the thing that we will be using in this problem, that the area of XMN is equal to the area of YMN. The area of XMN is equal to the area of YM and N. Right? Why is that? Why is that true? Because the area of a triangle is half base times height, right? And if you drop a perpendicular, both of these heights will be equal. Why? Why this height from X and why this height from Y are equal? Why are these two heights equal? Well, these two heights are equal. These two heights are equal because that's the definition of parallel lines. Another way to think about parallel lines is that the distance between the two lines is constant. The distance between the two lines is constant. So parallel lines are lines such that if you take distance, if you measure the distance between the lines anywhere, the distance is the same distance. Now, later in your life, if you pursue with mathematics, you will learn something about hyperbolic geometry and other things. So this notion of distance between two lines, this becomes very crucial at that point. The notion of parallel lines becomes very interesting at that point. So you can read about it in the internet. Anyway, coming back to this, in this picture, in the actual, so we want to use this particular for a theorem or sort of the result that in this particular setup, the one that we have here. So I want to say triangle AMN area, this area is equal to something. Can anyone give me another triangle whose area is equal to the area of triangle AMB? Area of triangle AMB is equal to some other triangle. Excellent. Very good. As most of you are realizing that this is just ABC. This is just the triangle ABC. Okay, can anyone tell me why that is true? Why is that true? Why is it ABC? So we are using that previous result that CD is parallel to AB. Both of them have the same base, AB, and their vertices are on the line that is parallel to the base. So base is AB. So base is AB. And the vertices M and C are on a line parallel to the base. So their areas are same. And this brings us to a very simple conclusion that area of triangle ABC is what? Can anyone tell me what is the area of triangle ABC compared to the area of the parallelogram? Area of triangle ABC compared to the area, exactly, it's half. Exactly. It is half of S. So diagonals, you can have this intuition that diagonals divide the parallelogram into two equal parts, and each of those equal parts have the same area. Each of those equal parts have the same area, right? So it's 1/4 of S. Excellent. Excellent. This is true. One half of S, sorry. Each of these pieces are 1/2 of S. Okay, can anyone tell me then what is the area of, maybe I can just clean it up a little bit. Again, you see, we are using visuals. We are using visuals. We are not actually using any area formula. We are using visuals, which is the most important thing. So what is the area? So area of AMB is half of S. So what is the area of ADM and B plus BMC? ADM plus BMC. So we know that AMB is S over 2. We already know this. What is ADM plus BMC? Excellent. Excellent. Because it's the remaining part of the parallelogram, right? It is the remaining part of the parallelogram. You already have ABCD. AMB is half the area. So this particular method is sometimes known as the method of complements. Maybe I can write this here. Method of complements. So to find out this ADM plus ADM plus BMC, we remove the A and B from the parallelogram ABCD. We remove A and B from the parallelogram ABCD. Okay, great. Okay, now let's focus on this little part. Maybe I can draw this in red, actually. So, what is the area of this little part and this little part? So, ADM plus BMC, this turned out to be S over 2. Okay, now can anyone tell me that what is the area of the red region that I have shaded? What is the area of the red region that I have shaded? You have to use the fact that AED plus BFC is 1/8 of S. You have to use the fact that AED plus BFC is 1/8 of S. See, we already know, maybe I can do this in green. So according to the problem, what is the area of the green? According to the problem, what is the area of the green? What is the area of the green? Green is 1/8 of S. We want to find the red. We want to know this. But we already know what is red plus green, isn't it? Can anyone tell me what is red plus green? We already found it. Red plus green is ADM plus BMC. This is ADM plus BMC, which is S over 2. Exactly. So red is S over 2 minus S over 8. It is 3/8, 3S over 8. Right? It is 3S over 8. Excellent. 3/8 of S. See how I have not used area formula at all, isn't it? Did I ever use area formula? I'm just piecing out the picture. I'm just piecing out the picture and sort of curving different portions of it using some sort of a visual logic, often known as visual logic as well. So this is 3S over 8, 3S over 8, right? Okay, now we are at the very last step. We are at the very last step. Okay. What is going on in the class? I don't know. This is pretty weird. Okay. Let me see. Okay. Okay, now can any of you tell me what is the area? This is the last step. We want to find out this black region. This is what we want, right? That's what EOFM is. We want to find out this black region. So what is COD? What is the area of COD compared to the entire parallelogram? What is the area of COD compared to the entire parallelogram? You can use the same sort of visual intuition. The COD is 1/4 of S. Because the diagonals, when they cross each other, each of the pieces are 1/4 of the parallelogram. But remember, don't be satisfied just by the intuition. Don't be satisfied just by the intuition. Can you prove rigorously? Can you prove rigorously that if you have a parallelogram, the diagonals will split each of these pieces in 1/4 of the entire area of the parallelogram? Can you rigorously prove this? So rigorous proofs are not part of these seminars. These are part of the actual course. So I cannot go into that. But this is something you should always remember. You should always take help of intuition. But remember, intuition is just intuition. That's not mathematics. To do mathematics, you have to be rigorous. Okay. So we are ready to talk about the black portion. Black plus red is 1/4 S. We know that black part is 3/8 of, the red part is 3/8S. So you can now finish this up. Can anyone tell me what is the black part now? So the black part is 1/4S minus 3/8S. Black part is this. So you see, Rishikesh is absolutely right. That looks like negative 1/8S. Isn't it? How can area be negative? How can area be negative? It cannot be negative, isn't it? It's negative 1/8S. So when this problem was actually asked in, I think in a Romanian Math Olympiad, they made this error. They made this error in actual values. So the value of AED plus BFC, this thing, cannot be 1/8S. So this is your challenge. The challenge problem is really this. Can you fix this problem so that it has a correct answer? It has a more believable answer. Of course, area cannot be negative. So can you fix the area of AED plus BFC? It cannot be 1/8 of S. It's giving us a negative answer. It cannot be 1/8 of S. So maybe it can be something else. Maybe it can be something else. And you would get a proper value for the area of EOFM. So you have to think about it. So Prachir is saying it is 1/4. That's not true either. Then EOFM will become 0. Maybe you have to think a little bit more. Maybe you have to think a little bit more. Okay. So it is not 1/8. Maybe you cannot reduce the area of AED and BFC, the sum of that. It has to be, yes, you cannot reduce that. Okay. So now I will finish it off by reminding you that we have the Math Olympiad coming up, and this is chinta.com/Bose. This is coming up in the month of July. You can always attend it. You can go to chinta.com to see further courses on mathematics Olympiads that we have. We have both one-to-one classes and group classes, which makes the entire process very personal. And if you are referred to this program by some of your friend or your school or some training center, they might have a course access code that will reduce the price of our main courses. So you can talk to them. Okay. For today, I'll stop out here, and I'll meet you again next week, same time. Thank you. Bye, everyone.